Welcome back. This is Mr. Hassan's Maths channel, and I'm going to answer a question from an old paper, June 2013, an R paper from C2, which this particular topic relates to P2 of the new syllabus. It's about trigonometry and solving tricky equations. And I'm going to answer this question specifically because of a viewer and the questions that the viewer is asking about one of the questions that I already answered in another paper, but this is a similar type of question. And I'm just going to go through this question, keeping in mind the points that the student has doubts in solving such a question. And it seems like these multiple and compound angles is something where the student needs some further explanation, as well as the difference between using the ASTC and the using the symmetry of the graphs. I'll show both ways of how to deal with finding the angles, just to clarify in a manner that maybe students might be used to as well. So now we want to solve this equation for values of theta between 0 and 180. Okay, I'm going to also show you how we would have solved the question if the limits were between 0 and 360 as well, just to give you an idea of how to deal with it. And I might elaborate a bit more and change those a bit, just to give you an idea of how to deal with different types of questions. So first of all, we have to first make the sign of the angle the subject, all right? And the angle is this whole thing is the angle, everything inside the bracket. Okay, this 2 theta minus 30 is all the angle that we have the sign of. Okay, so I'm going to subtract 1 from both sides, so I'll be left with sine of 2 theta minus 30 degrees. This is the sine of this angle, is equal to 0.4 minus 1, which is negative 0.6. Okay, 0.4 minus 1, which is negative 0.6. So now we're going to take the inverse sine of both sides of this equation. This side will be left with 2 theta minus 30 degrees, and this will be inverse sine of negative 0.6. Okay, now when I am finding my angles, I have to make sure that I collect the angles in the correct range. I don't go outside of the range, don't collect more angles than I need, and I don't miss out any angles as well. So what I have to do is I have to make sure that the range fits what it says over here. So if it says theta in the range and here it says 2 theta minus 30 degrees, I have to change this theta to say 2 theta minus 30 degrees. Okay, but whatever I did to this, I have to do to these two. So if I multiply 0 by 2, it stays at 0. Then I take away 30. That's going to give me negative 30 degrees. So I have to collect angles starting from negative 30 up to, and 180 multiplied by 2 is 360. 360 minus 30 is 330. So I can only collect angles within this range. Okay, and then in the end, I have to write my answer in terms of theta, and you'll see what I do at the end. So now I'm going to find the inverse sine of this angle and the answer to 1 decimal place. So I'll write them to more than 1 decimal place, and the final answer I'll round to 1 decimal place. So I need to be in degree mode here because we're dealing with degrees. So I have to change my calculator such that it's in degree mode, which I've done, and then I press inverse sine of negative 0.6. Now that's going to give me an angle which is negative, and it's negative 36.869. So I've got 2 theta minus 30 equals, now the angle we've got here, negative 36.869, negative 36.869, continuing on. This angle is outside of our range. This is outside of our range. Our range starts from negative 30, okay, and goes up to 330. So we cannot take this angle. This angle is rejected. However, we don't just throw it away and forget about it, because this is called the principal angle. From this principal angle, we are going to find all the other angles in our range. Okay, and this is where I'm going to bring into our understanding what we know about the two different ways. Now, I personally prefer to think about the symmetry of the sine curve. So I'll show you how to deal with it first in that way. Okay, so if here you have your sine curve. All right, and you don't actually have to draw it every time, because once you understand, you can just you can just go ahead and just do the calculations. But this is where the understanding comes from. So I'll show you exactly what we have. So the first angle we found, okay, was negative 36.869. Now that's not theta, that's just the whole of this angle. In the end, we're going to find theta. So the angle that we found is somewhere over here. If this is 0, for the sine curve, this is 180. Sorry, this is 90 what I'm talking about. Let me just do that again. I've drawn it too small. I'm going to go up to 330. So it's going to look something like this. That's better. Okay, this will be a bit more pronounced, like that. Let me just tidy that up a little bit. Okay, so here we have our y-axis, our x-axis, our 0, and it's going to go down and come back. So what we found, this is 90, this is 180, this is 360 here. Okay, so those are the angles. That's the sine curve. That's the sine of a angle, not theta here, but a angle. The angle we found here is negative 36.9. I'll just round it for one place in this for the diagram. That angle is outside of our range. The angle that we're looking for is between minus 30 here up to 330 here somewhere. Those are the angles we can use. So I can't use this angle here. But what I can do is I can use this to find the angles that might be in the range. So there's definitely going to be one here, and there might be one somewhere over here depending on where it goes up, right? So how do I find this first angle here? Okay, well, from the symmetry of the sine curve, okay, this angle is the same distance from 180 as this is from 0 on the other side. So basically, for the sine curve, what you do is you always do 180 minus the principal angle. To get the other main angle for the sine curve, you use the symmetry of the curve. So you do 180 minus the angle that you found. So 180 minus the principal angle will give you the other main angle. And that particular angle is in our range because you do 180 minus 36.869. So if I take this angle here, which I'll store as A so that it's store as A. Okay, so if I do 180 minus that answer, I'm going to get 216.869, which is in our range. 216.869 degrees. So that's in our range. And then I'm going to check if this angle is also in our range. What we do is, once we found two main angles, this is the first main angle, this is the second main angle, to find the other angles in our range, we know that the sine curve repeats itself every 360 degrees. So 360 degrees away from here will be another angle which shares the same sine ratio. And 360 less than this, which is over here, will be another angle which shares the sine ratio, which is outside of our range. But just if it were in our range, that's how you'd find the other angles. We would add and subtract 360 to these main angles. All right, so now if I add 360 to negative 36.869, so I'm going to take this answer here. Whoops. One second. I'm going to recall my last answer. I'll recall A. Okay, so that's my answer A. So that is negative 36.869. If I add 360 to this, okay, that's going to give me, whoops. What did I do here? One second. Recall A. I just saved the wrong one. Second, sorry. I messed up there. This is my answer. There's my answer. Okay, that's the answer. That's the answer we get. If I add 360 to this answer, what do I get? 323.130, which is inside our range. So I'm going to take negative 36.869. I'm going to add 360 to that, and that gives us an answer in our range, which is 323.130. 323.130 degrees. So this angle is in our range, and this angle is in our range, and there's no other angles in our range. Okay, so these are the two angles in our range, and then we can find what theta is. We know 2 theta minus 30 degrees is equal to 216.869, and we can find what theta is. And we know that 2 theta minus 30 is equal to 323.130. And we can find what theta is. We have to add 30 and divide by 2. Okay, but I'll also show you how to use the ASTC, or some people call it the CAST diagram. Awful STC, I call it, or amazing STC, depending how good your internet is. If you live in Saudi Arabia, you'll understand what I mean. All right, so now here we have all the ratios are positive, sine, cosine, and positive. The sine, cosine, and tan, sorry. Or only the sine is positive here, only the tan is positive here, and only the cosine is positive here. ASTC, first, second, third, fourth quadrant. So the angle that we found from our calculator for the main angle here is basically negative 36.869. So we found an angle over here. Okay, this was our angle, negative 36.869. 869. If you go clockwise, you end up with a negative angle. This is where 0 is. This is 90. This is 180. This is 270, and this is back to 360 again after one revolution. Okay, now, so we're looking at the place where the sine gives us a negative ratio, which is in the third and the fourth quadrant. In the first and second, sine will give us a positive ratio. So our angles will lie along these lines. Okay, these two lines here. Now, we have to start from 0 and go. We have to start from negative 30 and go upwards. Now, this angle is out of our range because we can start only from negative 30, which is over here. Okay, and we go all the way around to 330, which is back here again. Okay, so it's back here again. So it's from negative 30 all the way to 330, which is basically along this line, going in this direction. That's as far as we can go. So we can only find angles in that range. So what is this angle over here? What is this angle over here? What is this angle over here? Well, we know by the fact that we have some symmetry here, basically. The associated acute angle, this angle here its magnitude is 36.869. So this angle here is 36.869. So if I want to find what the whole of this angle here is, it's 180 plus 36.869, which is what gave us this value here, 180 plus 36.869. It's 180 minus. Okay, so in this case, because it was a negative angle, it ended up being a plus. If this was a positive angle, okay, if this was an angle which was positive like this, then the other angle would be in the because it would give us a positive. The positive ratio will give us a positive angle for sine. You would then have the other angle would be over here, which would be 180 minus the angle. In this case, what I'm saying with my symmetry diagram, for the sine curve, you get the main angle using inverse sine. Okay. Now, whatever that angle is, all you have to do is do 180 minus that angle, and it will give you the other main angle. 180 minus this, if it's negative, will become 180 plus it, because we have minus. If that's positive, it will be 180 minus 36. It will give you the angle over here. Okay, but here it's a negative ratio, so our angles are over here. Okay, so that gives you 180 plus, okay, 36.869, which is the angle we got, 260.869. And now we got to also find what the angle is all the way down to here. Okay, this angle starting from 0 all the way around to here. And we can see that basically this is like the whole revolution, 360 minus the magnitude of this, which is 36.869. Take away the size of this angle. So it's 360 minus this amount, which is 36.869. And that's the same as you get when you add 360 to this. You go all the way. If you add 360 to this, you're going to end up getting the same thing. Minus 36.869 plus 360 will give you the same as 360 minus 36.869. And you end up with 323.130. Those are our two angles. They're not our final answers because we have to now find what theta is. So we got to take the angle 216.869. Okay. Let me just find it. Okay, let me just so let me just get this. Okay, so we did 180 minus the answer, and we take this, we have to add 30 to it, and then we have to divide it by 2. And that gives us 123.434, 123.4349 going on. And this angle, okay, we're going to go back to this, and we're going to take this angle and add 360 to it. And that gives us 323. And then we have to add 30 and divide by 2. And that gives us 176.565. 176.565. And in the end, our answers have to be to one decimal place. So we have theta equals 123.4 degrees and 176.6 degrees. Those are two answers, and we can see they are within our range from 0 to 180. So the two different methods that we can use, I personally prefer this method here because there's no fluffing around with all this, associated acute angles. You just have to understand from the symmetry of the sine curve that whatever angle comes out from your calculator, to find the other main angle, you do 180 minus that. Okay, whether the first angle is in your range or not, it doesn't matter. Okay, because that will generate other angles in a range. So you do 180 minus the angle that comes out of your calculator. So in this case, it's 180 minus to end up with 180 plus. So you get the other main angle. These are the two main angles. Okay, the two main angles are this angle and this angle, and they will repeat again and again every 360 degrees. Why? Because a sine curve has a period of 360 degrees. It repeats every 360 degrees. So 360 degrees away from this point here will be the place where the curve rises up again like this over here. Okay, so it goes down and rises up again. And that's one of the angles that we found. When we added 360 to this, we got this angle in our range. Okay, so we got this angle by doing 180 minus this angle. So 180 minus 36.9 gave us the angle that we had here. And then we got this angle here by doing this angle plus 360, because it's 360 away from that. If the range was wider, okay, if I had to carry on and get angles, further along, like up to 720, I would just keep adding 360 to these two main angles. And if my angles had to go back to negative 360, for example, I would keep subtracting 360 from these two main angles. This is the first main angle here, and this is the second main angle here. All right, so once you've got these two, okay, even if one of them is not in the range, you can get other angles within the range by adding and subtracting 360 to and from them. For the sine curve, the main angle, 180 minus that angle, and then add and subtract 360s. If it's the cosine, the symmetry is different. For the cosine curve, the symmetry is different. Looks like this. So your angle will always come out as positive from your calculator, even if it's a negative ratio. A negative ratio will come out somewhere over 180. So whatever angle you get in your calculator, the symmetry of the sine curve is such that there's another angle that shares the same cosine ratio for the cosine curve, okay, but it's 360 minus this angle. Okay, so this distance and that distance is the same. That is whatever that angle is more than 0, and that is whatever that angle is less than 360. So for the cosine curve, you find the main angle with your calculator and you do 360 minus that main, and that gives you the other main angle. And then you can just keep adding 360s to and from those to get all the other angles. And the tan curve is even more straightforward in terms of finding, the other values, because the tan curve, basically, it doesn't have that that symmetry that these have. You just basically get whatever angle you get that angle, and then that angle just repeats every 180 degrees, because the tan curve repeats every 180 degrees, not every 360 degrees. So whatever angle you get, you just take the angle, you keep adding 180 to it, taking 180 from it, until you have got out of the range that you were given. All right, so I find the symmetry of the curves way easier to deal with than using the cast diagram. You just have to understand for the sine curve. I'll write it down here. For the sine curve, okay, you get the calculator answer, and that's the first main angle, and the second angle is going to be 180 minus whatever you got from your calculator answer. And then after that, you take these answers and you add and subtract 362 and from them. Add and subtract 362 and from them to get all the other answers. Okay, that will give you those answers in the range. For the cosine curve, you get your calculator answer, and then the second step is you do 360 minus the calculator answer. Sorry about my bad writing. Okay. And then after that, you take your angles and you add and subtract 360 to them and 360 from them until you're outside the range. Okay. And of course, if this is in terms of pi, you'll do pi minus and 2 pi minus. And here you'll do plus or minus 2 pi plus or minus 2 pi. Okay. And for the tangent curve, the first thing you do is, again, the calculator answer. That's the principal solution. Okay, whether it's inside the range or not, it doesn't matter. You use that, and the other angles, in fact, all the other angles, after that, you just take this angle and you add and subtract 180. There's only one main angle, okay, for the cosine, for the tangent curve. And it repeats every 180 degrees. There's none of that symmetry kind of thing in the tan curve. Okay, so there's none of that line symmetry there in the tan curve. So you just basically, whatever answer you get, you keep adding 180 to it and taking 180 from it until you've exhausted the range that you have. Okay, so the points in this question that are important are to change the limits according to what's written here, and then that's where you start collecting your answers from. That way you don't lose any solutions. Okay, and in the end, you have to, adjust your answer to find what theta is. So you take, in this case, you add 30 and divide by 2. Add 30 and divide by 2, and you'll find that if you did it correctly, your final answers will be within the original range they gave you, as we can see. All right, so I hope that was clear. All right, I hope I've tried to go into a bit more detail here to explain how to deal with such questions and how to understand them according to my preferred way, which is the curves, and the other way, which is ASTC. All right. So hopefully the student who was asking me the questions, I hope this clarified your misunderstanding and that you understand what to do now. If not, please just leave a comment, and you can maybe give me a question that you want me to answer to clarify it further, and I will do so. Anyway, this question will be saved under the playlist for the June 2013 R paper, or C2, which will be in the which will appear in this region here at the end of the video, sorry. And it will also be included in the playlist for P2 trigonometry, okay, trig equations and identities, which will be in the playlist that will appear in this section over here. You can subscribe to my channel by clicking on this link, and you can also watch this video that will appear over here that shows you how to use my channel to find what you're looking for in a quick way. Thank you for watching, and see you soon.